Hi everyone, welcome to today's session. My name is Shri Krishna. I'm your learner success manager for the day. Before we go ahead with the session, please let me know if my voice is loud and clear. You can confirm in chat box. Thank you for your confirmation. Let me do a quick audio check with our instructor. Hi Rahul, for audio confirmation, let me know if my voice is loud and clear.
Yes, it is loud and clear, Shri Krishna.
Yeah, we can also hear you clearly. Now I will make you the presentator so we can get started with the session. Happy learning everyone.
So, hello everyone. Good morning, good evening. So, let me share the screen stating that we'll be starting shortly because let's wait for everyone to join in and then we'll continue. So, sharing a screen that will be starting shortly, and I'm currently muted. Hello everyone. I hope everyone is doing well. Please give me a few seconds. Okay, so welcome to Applied Data Science with Python, everyone. So our previous course was a programming refresher course in which we learned about what is a software, what is a hardware, what are various programming languages, and we studied Python and in detail as well, like uh, how does Python work, various syntaxes, various loops, XYZ things. So we studied a lot around that as well. Now, post that, we ended with studying all the classes and every part of Python. Now we are in this course. So for anyone who is completely new to Python and has joined this course for the first time, and you're completely new to programming and completely new to Python, I would highly recommend you to please go and watch the programming refresher session first, because this particular course will be built on top of the knowledge that we gained in the previous course. Okay, saying that, said that, now all the people present in the class currently, I hope, has knowledge around how Python works, what is Python, how to program it, how to write loops, functions. So all the people present in the class are aware about those things now. That is my understanding, because that is what is required in fact. Okay, so what we'll be doing in this course? Let's talk about that now. Okay, please give me a second. Let me share the screen. I hope my screen is visible to everyone. Please give a thumbs up if yes. Okay. So this is practically the theme. Your course name might be different, MSAI and all those things might be added in front or back. But the theme is essentially applied data science with Python. In this course, what we'll be doing is, first of all, the prerequisites for this is only one prerequisite. That is, you should be aware about Python programming. Okay. You should know how to write Python code, all the functions, and those things are mandatory for us to move ahead in this course. So if you're completely new to Python, so you should be not in this course, you should be in the previous course. Okay. Now on top of this, what we'll be doing in this course, let's just, take this first now. So contents in this course will be So first of all, we'll talk about what are libraries, the concept of libraries or packages in Python. What is the use of them? Uses, like what is the use of them? Okay. Post that, then we'll talk about various libraries. We'll start with NumPy library. As of now, this name is completely new to you. Don't worry, we'll be talking this in detail. Then we'll be talking about Pandas library. And what these do, don't worry, we'll talk about. First, I need to tell you, first of all, what is a library. Then only it will make sense. And post that visualization libraries like Matplotlib and Seaborn. And in parallel to this, we'll be also going through various concepts of maths and statistics. So stats and maths. We will be learning about uh, hypothesis testing, probability distributions, and various tests around it. So various tests in it. Okay. Various measures around the data, and other concepts around outliers, scaling, and those many things. Transformations, on data types, on outliers. So we'll talk a lot more on the theoretical part as well. Okay, so that it can give you understanding. So this is the content for this particular course that we'll be doing. And yes, so any questions anyone so far? And this all thing will be taking the whole course uh, classes to cover up. When was the previous course? It should be visible in your LMS portal away. Okay. So any questions anyone so far? Okay, perfect. So let's start with the concept of libraries and packages in Python. Only one course has been conducted so far, the programming refresher course, which was also talked about in the induction. Okay. No issues if you have gone through the video, that's enough. So I'm not saying the prerequisite is going through the previous course. The prerequisite is if you're aware about Python programming, that is what is required. Not going through the previous courses, not the requirement. Simply you should be aware about Python programming. Could be through YouTube videos, could be through reading books. That doesn't matter. Could be through the course that we have conducted. The only requisite for this course is the Python programming awareness. Okay. Any more questions, anyone? Two weeks course was not available. Only 3 classes were conducted away in that, and before that in induction it was told the first course will be programming refresher if you have attended the induction. Okay. No issues, you can go through the recordings. Recordings will be for sure available in your LMS portal. So what you can do is, yes, Abhay.
Hi Rahul.
Yes, Abhay.
Yeah, the last week you told us that last week's session is cancelled. I understand that one, but last week was also cancelled. But we are not ever with that.
Only three classes were conducted for Python programming
I
refresher.
know.
So if
Three
okay, see, I
classes.
say okay, okay, wait, wait.
I was available, but last week means it means 15 days class was not available.
My
So
first question, my first
last week class, you told us that next week the class is not available. I understood that, but last week also class was not available, and I didn't get any reminder, and I didn't get any reminder from the Simply Learn, and they didn't say anything that class is cancelled.
okay, let me answer
And
those.
I was waiting for that till 2 o'clock.
Okay, let me answer that now, Abhay. Okay.
Yeah.
Okay, first thing, were you present in all the three classes that were conducted for
Yes.
Python programming refresher?
Yes.
Okay, so that's it. So your programming refresher course is done.
It
There was
means
a
there
gap.
no
Please,
there was
please
no
wait, Abhay,
other classes,
Abhay.
right?
Okay, please continue.
Yeah. So it means there was no there is no other classes, right? Because I thought that I missed that class.
Okay, that is what I was
Last.
answering, Abhay.
Yeah.
So what I was saying is that for the first course, the programming refresher, there were three classes. Okay. First thing, in between the 4th and 5th July, week was cancelled due to the Independence Day part. Okay.
Yes.
Total number of classes were three, and it was not cancelled, it was off, you can say. It was not cancelled, it was off. That is how you can put it. Total number of
Yeah.
classes were three for that course. All three were conducted. After every course, Simply Learn gives you a 1 week break. So the previous week which you are mentioning, it was not cancelled, it was a break because this course which you are present currently in is completely a new course, the second course. So
No,
between
actually,
any two
yeah. Continue.
so between any two courses, there is a 1 week gap.
Yeah.
Okay. So is it
So
clear? Any
actually,
questions?
yeah. So the question is that in between 2 weeks, I have not attended any classes.
There were no classes available.
So that's what I'm saying. That in between 1 week, I can understand. 2 weeks, you said 1 week. I understood that one, but last week also
Okay, can you tell me when
we
was the
have
last
not
class that you attended?
20 20 something, right?
Not 20 something. Can you give me the exact date?
Yeah. I'll tell you. Wait. So today is 12. Today's 12. Fifth is I was not under at the fifth class. I was saying.
There was no fifth class available. There were only three classes. Last
No.
class for okay,
Fifth
last class for
date.
Python
5th
programming
of July.
refresher was conducted on 22nd
5th of
June away.
5th of July.
5th July there was no class away.
28.
Only three classes were there. So
No. 28.
there were no classes on 28 as well.
Yeah, that's what I'm saying. At end of the 22, you said that there is no classes on 20. Wait, 28. I understood, but no one said that there is no class on 5th. So that's what I'm asking.
It
I'm
was
not
all
saying
it was a off
I'm,
away. It was a off.
it was off, but how I know that it was off? But simply
Using
learn
your
should
LMS
have.
portal away. If you log into
Yeah,
your LMS
I
portal.
was using the MS portal, but they have told us that fifth every week the class is available. No, I'm not saying that it's your fault. I'm saying that Simply Learn didn't inform me.
So that would be for that you'll have to have raise a ticket and talk with the program manager or
Yeah.
Simply Learn team, correct?
That's what. So no,
Because I
that's
am
what I
not
am
one who
asking.
is
That
assigning the courses and dates.
yeah. So that's what I want. I wanted to understand that is there any classes? There is no classes means I'm fine.
Okay.
Yeah.
Okay, so let's continue. So I hope my screen is visible to everyone. Okay, perfect. So let's talk about the knowledge. So these are the contents that we'll be doing, and this is the prerequisite. Okay, so let's start with talking about what are libraries in Python. Okay, what is the concept of these libraries and why we need them and what we need to do with them. Okay, okay. So let's say just let's try to think about something. For example, every day you would want to let's say if you're in some accountancy business or something in accounts, or let's say your project involves you to do some addition subtraction, or you want to have a calculator in Python. Let's say you want to write a code for making a calculator in Python. Why so? So that you can simply click on like a window opens up and you can simply click on these multiple buttons and do the whole addition and subtraction, whatever you want to do. Okay, so you want to write code for this. Okay, this is your intent, or you can say you want to have this to make a calculator in Python. Why you would want to do that? For making your day-to-day life easy, or you might have some use case for it in your business that you would want to have a calculator. Now, for example, this is your use case, but same could be the case for many people. Hundreds to hundreds or thousands of people would want a calculator in their day-to-day business, and in case if they're using Python, correct? That could be the case. And same intent of user or users would be to have a calculator in Python. Now the question is, this could be, as I mentioned, could be an intent of a lot of people to have this particular thing, a calculator. This is a GUI basically, graphical user interface. Okay, or a simple UI. Now, what you would do is in in a normal condition, or you can say what you would do is you would write the code yourself. Write the code. Let's say there is a this person name who needs this, so you'll write the code and make this calculator. Same way, there is a person B who also needs this. He'll have to write the code again by himself or herself. Write the code and get the calculator in their uh, system. Okay. Same goes for person C. Again, write the code and make a calculator in your Python. But don't you think that this process is very much repetitive? Could it not be that okay, someone who could write the code, publish somewhere? So should it not be? For example, what do you think? Should it not be that someone writes a code for once and all and share it on some website? Just giving you a naive idea on some website from where everyone can download and use it. Everyone can download and use it. And once a person is Okay, so I'm back, everyone. I suddenly dropped due to some network issue at my end, but yes, thank you for your patience. Okay, so let me share the screen and let's continue with where we left off. Okay, so what we were saying is that, okay, let's say if the user wants to make a calculator in Python, so they'll write a code. Okay, so they'll write a code to make this UI thing. Let's say there is a user A, user B, user C. Everyone wants to kind of have a calculator because in uh, could be that they might have similar requirements and they could be present all across the globe as well. Correct? It's not necessary that they belong to the same team. That could be the case that they might belong to the same team or whatever things basically. There are multiple users who would want to have a calculator. Now, don't you think should it be the case that someone writes the code for once and share it on the some website from where everyone can download and use it? And when everyone is able to download and use it, what do you think? What will happen? Saves time and resources, correct? And if someone wants to still spend time and resources, existing code can be made better. You already have a baseline or whatever code the person has given on the website that can be still enhanced, correct? Getting it? Don't you agree with me? What do you all of think? What do you all think? Sorry, isn't it ideal case that should be the done? That should be done. That someone writes a code and publishes somewhere from where everyone can download and use it. So that is what really happens. That is what really happens. So this is the concept. So this concept is actually implemented in fact. Okay, this concept is actually implemented. So the existing code, just give me a second, let me, instead of existing code, so the code written and published, you can call that as a library. You can call that as a library or a package, whatever you want to call it. Okay, library or package. Now the question is, where is it published? So for Python, we'll go to that website. It is a py index where it is present. We'll go to this. It has a URL as well. Okay, how to download, we'll talk about all those things. But so far is the concept clear, like what is a library? So the library is a code that has been written by someone. Of course, if I go much more technical, a library has many modules, many functions, many classes, a very well properly written code which has been packaged, has been has all the requirements.txt file, various supporting files, and all other things. What is required with a well written code, in fact. Okay, someone has written the code, has uploaded it at a particular place for everyone to download and use it. So this particular code, we call it as a library or a package. Okay, for example, now the names that I was mentioning above, this NumPy, Pandas, Matplotlib, Cbon, all these are libraries. Okay, all these are libraries. What do they do? We'll talk about that. Okay, but this concept is the concept behind libraries, so that we all do not have to, if there is a common task, we do not have to write the code again and again and again and again. Simply go to the place, download it, and use it, as simple as that. Now what is this py index? Now that is what we'll be talking about. So let me open up the browser and I'll be sharing the screen. Please give me a few seconds. Is my screen visible to everyone? Okay, so as simply when simply write py index, so this is what comes up, the Python package index. Okay, let's so this is the first website that will simply come up. Once you click on it, so this is the official Python in plain sense. I'll refer to the plain sense instead of calling it index. This is the official Python website for uploading various libraries and packages. As simple as that. Okay. How it's an index, but still it's a place where anyone from across the globe, following certain rules and recommendations give set by Python official team, you can say, or set by various norms, can upload their code. For example, let's say you are the one who has made this calculator code. Okay. Now you would want to upload it so that everyone can download and you would want to help them in such a way. So you cannot directly upload .py or your IP in a file. Okay, this is the code. You'll have to package it. That's a whole separate game where you'll have to have some environments, various modules, classes. There is a certain guidelines that you'll have to follow. But in plain sense, anyone can upload their code over here, and from this place, anyone can download the code and use it. Okay. So if I just go down and show you, just give me a second. Let me check my audio. Okay, I got it. Just give me a second. I hope I am clearly audible now. Okay. So just to repeat a few last few sentences if the audio was not right. So what I was saying is, in plain sense, this is the website where people come and upload their code. However, it's an index, but in plain sense for anyone who is completely new. So as I mentioned, that people can upload their codes and anyone can download their codes. So this is a Python official website where anyone can come and upload their codes. If you think that okay, it can be helpful for many people, and this is a common thing that people would want to do, correct? So this is place where you or any person across the globe can upload the code. But it is not as simple. When I say as simple, what do I mean by that? Like you cannot simply come and upload your .py file, one single file, or .ipno file, one single file. No, because you are uploading a library, so it has to follow certain guidelines, like how your code should be present and what all supporting files it should have. It should be packaged properly. For example, let's say if you want to share certain codes with me or certain images with me. So, what would be the ideal case? Sharing it in a single folder, zipping it and sharing it, or simply throwing all the 100 images parallelly or simultaneously? Which one will be much more organized? What do you think? Sharing it in a folder, correct? Correct. So that is the case that there are certain guidelines for anyone to upload the code over here. It's completely free. You do not pay anything for uploading a code, but you have to follow certain guidelines and certain recommendations to do that. But again, that's a separate thing of publishing a package of your code. Those things are different. But coming back to the topic, this is place where everyone who feels or teams or organizations, in fact, not only individuals, teams, organizations, who feel that okay, these are the things that people would want to use, these are common things, they tend to upload it over here. For example, various libraries like TensorFlow, which was released by Google, is present over here. A pandas library, initially written by Wes McKinney but currently kind of managed by a lot of people. NumPy, visualization libraries like Plotly, a whole organization is there which manages the Dash and Plotly libraries. So from individual contributors to organizations, everyone tend to upload their codes over here. So currently, you can see over here that there are approximately 657K projects or libraries over here. Okay, and for these, there have been this much releases, approximately 7 million releases, and approximately 40 million files are present in these packages or projects. Okay, Manoj, that will be totally internal, no? if an organization want to make a package and completely want to keep it internal, so they'll host it on their Git, organization Git, or any some place which. So Python also supports ways of downloading codes from Git, private Gits, and those things. But again, this is with respect to public. What you're talking is completely the internal part. But yes, okay, like even the codes can be packaged and shared as a wheel file, zip file across the whole organization. Please give me a few seconds. Okay. So this is the place where packages or libraries are uploaded. Now, just to search few of them, for example, now your question would be, so how do I know which library I need to use among so many packages? The answer is you'll have to look, you'll have to browse yourself. Okay. And this is what is the case over here. No one points you directly, okay, if you want to do this, this is the library. No, if you want to do this, this is the library. Just for making graphs, there could be hundreds of libraries present over here. The most commonly used libraries are Matplotlib, Seaborn, Plotly, okay. But there could be many, many more libraries which do visualization. Now you have to figure out, in case if you do not want to use the commonly used libraries, that okay, I want to use some other thing. You will have to browse it by yourself based on this. Of course, for every packages, there are multiple tags that are associated that can help you to search and all those things. Okay. For example, let's say I'm saying NumPy. What is NumPy? NumPy is a package. What it is used for? It is used for doing numerical mathematical calculations. So if you see, NumPy comes over here. Fundamental package for array computing in Python. Let's click on this just to see what it is. Okay. Now see, this is the page, or you can say page for NumPy in this PyPy index. Okay, so this is the project description that okay, this is a NumPy library, and now NumPy library itself has a whole home page as well. Let's just to show you that. Just to show you that. So this is the whole page of this NumPy library. Okay, how does it work? What are all the things? How do you write it? We'll talk about these things. Don't worry. Okay. So this is how the page looks like, various release histories, when was which version released, what is the current version. Okay, so all these things are shown over here. Then you can also see, okay, what are various downloadable files inside it. So 20.4 MB source distribution file, various build distributions. None of you will not be using any of these. You'll simply use a pip install command. But again, just to give you an input on this part. So these four are the maintainers of NumPy. Okay, and documentation, downloading it, release notes, source code. So even the source code is present of NumPy. So most of the libraries are open source, but not necessarily that every library will be open source. NumPy is open source, and this is the whole source code of NumPy. Okay, how NumPy has been written. You can see it is used by 3.4 million users. 1,763 people have contributed to this library. 61% of this library is written in Python, but there are parts of C, C++, and various other things as well. Okay. So far clear, everyone, how we are going and what we are doing currently. Library can be duplicate. When you say can be duplicate means, if you download it in your system, so you're downloading that library. You're not making a duplicate of it. You're simply downloading it. It's not lively connected to this website. Means if you change the source code in your system, will the source code change over here? The answer is no. It's like downloading a photo from web. You do whatever changes you want to do in that. It will be present on your local system. It will not be connected to the web. Same is the case over here. Okay. But usually names are unique. If that was the question, like is the name unique? The name is unique. Yes. Okay, that's why you see NumPy 2425. There will be a lot of pieces like audio to NumPy, video to NumPy, multiple libraries. What we do, video reading into NumPy, load audio file into NumPy. So multiple libraries published by many people. For example, let's say if I want to see this video to NumPy, let's see who wrote this and who did this. So there is no documentation around this. There is no website for this library. So particularly, I can understand, okay, it has not been developed by any particular organization. It's not that organization supports it. Okay, so but okay, we see that there is one maintainer. This person is the maintainer for this library, and no contributors. So this is what this library is completely. Okay. Now what it does, of course, you can go into much more detail and see how it works. There is no official library chef. Okay. All the libraries are released by people or organization. Everyone is official in plain sense. But there are certain libraries which are really good, really well maintained, has proper documentation. Getting it? For example, just to relate it with the real world, there are many companies that make cars, bikes. There are then some big companies, for example, in India, Tata, Mahindra, Hyundai, and but there are other companies as well at lower scale which tend to make cars, correct? Which are authorized by government. They have licenses, but we do not know the names of them. But does that make them unofficial? The answer is no. Getting it? The only difference is that Mahindra, Tata, they tend to make a good, a lot of things are already present. So that is the case. So there are certain libraries. For example, NumPy, it is maintained by a lot of people. It is very well released, proper documentation, the whole mailing list, source code, everything is given. So it can be kind of, it is dependent. You can kind of rely upon it. That is how you can do, take it. But it's not that, okay, these are the official libraries, these are unofficial. No, no, that's not the case. Can we check for updates through this website to say NumPy or Pandas, which happens on a time to time basis? I didn't get that question. Shikhar. It's, yes, of course, it will be a risk, Rahul. Okay, now that coming to the security question. Can you trust all the libraries present over here? See, there are recommendations, but is everything checked by a person or a team? The answer is no. Okay, so you should always be careful about what you are downloading and using. So if you say that is NumPy safe, now because it is used by 3.4 million people, used by a lot of organizations. So what I can say is that okay, you can kind of rely upon it because it's open source. The whole source code is present of NumPy over here. Okay, and all the issues, tags, branches, everything is visible. So it can be relied upon. But do you still need to test it or check it? If you want to, of course, why not? No one says that this is completely secure. There could be terms and conditions which states that otherwise that okay it's completely free. No, we are not doing anything, and many more things would be present over here. But still, can has someone tested it for you line to line, code to code that it does not upload anything anywhere? The answer probably is no. Okay. That's why organizations tend to use commonly used, well-maintained libraries with whose source code is available. Multiple people tend to use it rather than to use some library which is completely new, completely basic, and rarely anyone uses it. For example, this project description unknown. We do not know. Okay, what this is. Okay, there is this person who has developed it. Would I use this library directly? The answer is no. Getting it? Does it make sense? What I'm trying to say, everyone. But if I go to NumPy, for example, so see, yes, I have a lot of information over here, a lot of documentations, a lot of people. I can see the source code. If I go to their GitHub page, okay, a proper GitHub page is there. 3.4 million people are using it. There are sponsors to this project, okay, and language informations, proper issue mentions, commit mentions, pull request, properly maintained. So now I can see that okay, this is not simply anyone is uploading, it has been properly maintained and is there have been 39,000 commits. So kind of good. Okay, so that is the case over here. Yes, Shikhar. Can you please rephrase your question and just put it again?
Hey Rahul, am I audible?
Yes, Shikhar, you are.
So what I wanted to know, like, if they like I have worked with NumPy in past also, like, and there are like updates that happen, like version updates and things change in NumPy as well. So like most of the times we are unaware of those updates if they're happening in those libraries. So is there a way that we can find out those updates, like if we can be notified by, like, say, PPI, or is there any way, like, or we have to every time go and check for newer updates on the web? That was my question.
Ideally, you'll have to go and check for the updates. But again, let's say you subscribe to their Git library, you follow it completely, any new commits are there, and new releases are there. In that case, you'll be aware about those things. But usually, you'll always have to follow. You do not get an email or something that, okay, we have a new version of NumPy or something like that. If that was the question.
Okay, okay, got it.
Mhm. Altaf, first of all, can you give me understanding if you are aware about what GitHub is? See, GitHub is the place where they are storing their code so that everyone can have a look. They are using it for their versioning and maintaining it. Okay, that code is getting packaged and they're kind of publishing it over here. Okay, so that is what happens. As simple as that. Okay, Git is a separate topic in itself, Lakshmi. So if you watch 3 to 4 videos from some online resources, you'll be completely able to understand what Git or GitHub essentially is. Honestly, not a very complex thing, in fact. Might look a bit technical for the first time in case if your background is not technical. So it might look a bit technical at the first view, but it's not at all in fact that technical. Easy to use. Okay. So that is what I was saying, that these are various packages. Same way you have, like, for example, if I search pandas, another library. So powerful data structures, for example, see a proper logo. So many maintainers are there, correct? A whole documentation homepage, proper information on authors and classifiers. Every proper information is displayed over here. They have their own website as well, in fact. Okay, for example, if I click on this homepage, it takes me to the pandas library website. So again, can I rely? Ideally, yes. Okay. So these are the most commonly used libraries. That is how we know it. Okay. So I hope the concept of pandas and these things are clear. Sorry, concept of the libraries and pipeline index is clear. Now the question comes that how do we install these libraries? Like, how do I use them in my code, or how do I install them in my system? That could be a very valid and common question as well now among all of you that you might be thinking. Okay, so how does it work? Let's think about it. For example, let's say, just everyone, please follow me carefully. Let's say you found some image online and you would want to edit it more. So what you do, you download the image in your system and then you simply start editing it. But let's say you do not like the changes, you kind of purge the changes and close your application. But now let's say if you want to edit again, would you have to download the image again? The answer is no, because it will be present on your system currently, correct? Because you already have downloaded the image, you can go and edit it again. Getting it? Or use it. For example, let's say, okay, just to make it much more clear, let's say you're making a PowerPoint presentation and you would want to use an image you found on web. Now what you do is you download the image and paste it in your PowerPoint, one of your deck, and you presented it. Let's say there are 10 more decks where you think that, okay, this image will be suitable in all these 10 decks. You simply paste it in every deck, correct? So what you are doing is you have downloaded image only once, but you are kind of using it in every presentation. So do you need to download it again and again? What is the first? Is this This is the first question. What do you think? Do you have to download it again and again and again? The answer is no, correct? You only downloaded it once. But for you to use it in every presentation, you'll for sure have to copy and paste it. Like you for sure have to insert it in that presentation, correct? If you're using it into 20 presentations, you'll have to insert that image in that presentation, correct? So same is the case with packages as well. You download them once in your system. You only download them once in your system, but in a code, if you want to use it, you'll have to insert it in your code in plain sense. So let's go back to the blackboard and let's discuss then this in detail. Just give me a thumbs up once my blackboard is visible. Okay. Perfect. Now the question comes, for example, we took an example and I like the same example because I'll be sharing these notes so that whenever you refer back, this example helps you to understand. You are making, let's say, 10 PPTs. PPT stands for PowerPoint presentations. Okay, this is the extension basically of a PowerPoint presentation. And you found an image online which can be used in all 10 PPTs. Okay, so what you would do, this is, let's say, the web, and this is the image. So you download it, correct? You download it on your local system, on your computer. And just to, instead of write your computer, so that now you have, and this image is now present here. This is the image present here. Just give me a second. Trying to make it as simple as possible. So now this image is present over here in your system. Now for our case, we have 10 PPTs, correct? You have 10 presentations from 1 till 10, 10 PPTs. So what you'll do, you simply copy paste, you'll simply insert it, correct, over here. Let me change the color so that it's easy to understand. So you'd insert in this, correct? Insert the image in this deck. Same will insert the image in this deck. Same will insert over here as well and over here as well. So in plain sense, you downloaded the image only once, but you can reuse it again and again and again in n number of decks. Correct? So same is the code, same is the case with the library as well. So same case, same implementation is there for Python libraries. What happens? Let me put in a star. So this is the PyPy index. Okay, and let's say this is a NumPy package. So what you'll do, you'll download it. Download on your system. Now it is present over here. Let's say now NumPy. Okay, it's present over here. Now you have 10 codes. Let's say So code 1, code 2, code 3, all the way till n number of codes, let's say. N number. 1, 2, 3, n number of codes. Now, for in every code, let's say you want to use NumPy. Now, what we will do with NumPy, we'll talk about that. Don't worry. What NumPy is used for, we'll talk about that in detail. But what happens is, please give me a second, everyone. Okay, so you downloaded it once. Now, what you will do is you'll simply import this. Now, I'll use the word import because in code you do not insert it, you import it. Okay, you import this library. And you can import it in n number of codes. Now, my first question, for importing NumPy in your codes, do you require an internet connection? What do you think? The answer is no. We do not require an internet connection for importing it. But for downloading the NumPy, do we require internet connection? The answer is yes. Okay, as simple as that. I'll not call NumPy as a function uh, aware. NumPy is a package which has multiple functions, multiple classes that we tend to use for solving our normal day-to-day problems in coding, of course. Okay, but it's a package. The right term would be package, not a function. So it's if you're relating it to a function, it's a function. Once you make it, you use it. Uh, you can do that, but the ideal sense would be because we do not download a function, whereas we'll have to download a library and then you'll have to import it. But if you want to relate it with defining and calling of a function, okay, we'll be coming to that topic. Okay. So I hope till this point everyone is clear. Any doubts, any questions so far? Please give me a second. I just let me make it a bit. Okay. Now the question comes, so how do we download? For the image, we know that we simply kind of right click and click on download and the image downloads on our system. Correct. But how do we download a package again, which is present on PyPy? So in plain sense, there are multiple ways that you can download a package in your system. But how do we download is let's talk about that. How to download. And please listen carefully. So you open up a, so the first step is open terminal or in plain sense command prompt or command prompt. So open terminal or command prompt Command prompt is, of course, based on system. Terminal can be opened from a IDE as well. For example, VS Code or PyCharm or Spider, they have their own terminal sessions as well. Correct? So you can do that as well. Or in case if you're using Anaconda, I'll use a bit of red color for this. In case using Anaconda, you can even use the Anaconda prompt. Okay. Now, once you open this up, you simply need to run the command pip write and run what the command. For example, pip install numpy. Like if I want to install numpy, pip install numpy. Now what this does is this at the back end hits the web. Okay, and it hits the web where at the py index. Okay, and then it downloads it in your system. Now what is this pip? This is a just give me a second. This pip is a package manager. It comes with Python. As of now, you should kind of ignore this, but this is a package manager. This is used for installing and downloading. So what it will do, first of all, it will download, then it will install what? NumPy. So this is where you pass in a package name. So just to put that thing as well. So this particular part is the package name or library name, just to use the word library only. It can change. You can kind of say pandas. It could be pandas, keras, and various all the other libraries that you would want to do. So pip install pandas, pip install numpy, pip install keras, pip install tensorflow. So this is how you install the libraries. That's it. Now, how do we import it in the code? We'll go and see that in Python code itself now. So any questions, any doubts so far, please put in the chat. Now, just one more thing. In case if you're using Anaconda, NumPy is already installed in your system. You do not have to do a separate installation. Okay. In case if you're using Anaconda locally, in case, just give me a second. So in case if you're using Anaconda, it's already installed. You do not have to install it. And if you're even using Simplilearn Labs, so it is also installed on Simplilearn Labs. You do not have to install it. As simple as that. Okay. However, this pip install, just to mention an additional point, additional info. Packages, or just I'm using the word packages now. Libraries can be installed from certain IDs directly. Means, for example, in Jupyter Notebook, if in a cell, code cell, you write and run this command, what command? Exclamation mark followed by pip install numpy. So this will install numpy in your system. Why would you want to find it? It's present in the, go to the Anaconda folder, go to the lib packages or site packages. That is where you'll be able to find the folder of NumPy. But we never tend to directly go to the folder and use it. It's present simply in Anaconda based environment. Go to the Anaconda folder and simply write NumPy in the search bar. You will be able to get the folder directly if you want to do that. Okay. So look for the Anaconda folder in your system and search NumPy inside that folder. That's it. So any questions, any doubts so far, anyone, please put in chat. I hope it's clear what packages are, how do we use them, how do we install them, what is their intent, everything. Any questions, any doubts, please put in. Just let me move this code a bit this side because it's going out of the sync. Benefits of using OneBot. Okay. I hope there are no questions then. Correct? Any questions left unanswered or by mistake, please put in the chat again. So now we have seen, okay, that how you can what is library, where are they present, what is the concept behind them, how do you download them, how do you use them. Now what we'll see, we'll go to a Python code where we'll be importing library and we'll be using NumPy. But when I say using NumPy, before using NumPy, we'll have to understand various cases or how NumPy is used and what NumPy does. Essentially, we'll have to talk about all those things. So NumPy, and before that, let's go to the homepage of NumPy library. Okay, let's do that. I hope my screen is visible. Okay, so as I mentioned, this is the homepage of NumPy library. Now, this tells you what it does and how it does all those things. So it's a very performant library. It's very fast for doing numerical calculations, and you'll be able to see. Compared to list, let's say you want to do some mathematical operations, you'll always prefer NumPy rather than using list or writing or your own set of codes. NumPy is much more easy to use. It's completely open source. It's, as it mentions, that numerical computing tools are there inside it for doing linear algebra, Fourier transforms, and many more things. Okay, you can even use this code, they'll show you that part. And it is used across a lot of libraries, and that is what it's trying to show you, from geoscience to chemistry to signal processing to quantum computing. Everywhere a NumPy is used in a way or another. And does everyone know this, what this is? This is the first image of black hole that humans were able to make. So in this, NumPy was used together along with many various other libraries to process the data. Gravitational waves detection, which was done certain just few years back, that was also done using NumPy, in fact, because a lot of data was kind of moved into through NumPy. Same way, sports analytics, which requires very high precision as well as fast calculations. It is done using NumPy in many cases. Okay. Also for doing deep learning estimations. What is deep learning? As of now, we'll talk about that. But various deep learning libraries, most of the deep learning libraries tend to use a NumPy way or another for doing their processing and capabilities. So very fast library. How so? Because it has bindings to C library, bindings to Fortran. That helps it to be very, very fast. Now, just to show you a bit around it, for example, now you might think, what is the use case of it? Rahul, you are saying that okay, it's very good library, but why would I use it? For example, let's say if you want to do some linear algebra, you want to do some integration or differentiation. Would you write your own code? Yes, you can do that. But what is the intention of having packages? Can you tell what is the intention of having the libraries? So that everyone does not have to replicate the same code again and again and again, correct? You can write that code by yourself. You can write a code of doing differentiation, integration by yourself. You can write a code of doing the matrix multiplication or getting a rank of matrix, a determinant of matrix. All those things, code can be written by a person. But these things have already been written in NumPy. So why would I write the code by myself? Okay. So in case, let's say if you want to do something around linear algebra, okay, if you want to do something around, let's say Fourier transforms, this is where the libraries, for example, if there is a linear algebra module inside it. So if I click on linear algebra, just to show you, so it can do all the operations in linear algebra, dot products, calculating the inner outer product of two vectors, computing the outer product of two uh, vectors, all the operations that you would want to know. For example, Chrome-Necker product of two arrays. Again, it's not necessary you would know each and everything in this because it completely moves to the mathematical parts. So in case if you would require them, you will come simply to this library. Getting it what I'm trying to say? Some decomposition, single value decomposition, singular values of a matrix. So this is where you, that instead of writing the code by yourself to figure out everything, you have this library which can do all these things for you. Calculating the eigenvalues or eigenvectors for a square matrix or array. Okay, calculating the norms, vector norms, determinant, matrix ranks. Okay, so all these can be simply done using NumPy library. For example, you might have, all of you might have for sure done this, just to talk about 2x plus 3y is equal to 8 and 6x minus 3y is equal to 2. Now find the values of x and y, correct? This you might have done for sure. So you can use simply this function to get these values, linear algebra dot solve. So you would want to do that in Python as well, correct? If your use case is to solve multiple equations that come in, find the best, what is the value of x and y. So would you write a code? Yes, you can. But NumPy already has that code written for you, so you would directly use it. Getting it what I'm trying to say, everyone? So this is what a NumPy has to offer you. A lot of mathematical formulations or functions that you can directly use. So all these codes are written at the back end. If you click on linear algebra.solve, so they'll tell you that okay, this is how you pass in the equations a comma b. They'll also show you example as well. Like this is how you pass in example, like x0 into 2x1, 3x0, 5x1. This is how you pass in, and they'll tell you that okay, the values for x0 and x1 was -1 and 1. Getting it? So this is the example of how to use NumPy library for solving these kind of equations. Because again, it's a programming language, so you'll have to follow the norms as well. When I say norms, you'll have to follow the syntax that how you will pass in the left side variables, how you'll pass in the right side variables, then how the whole thing runs. Are you getting it? What I'm trying to say, everyone? Please give a thumbs up. Same way as you can see, discrete Fourier transforms are over here. So if you want to do Fourier transforms, one-dimensional Fourier transforms, two-dimensional Fourier transforms, n-dimensional Fourier transforms. So you simply call in these functions and you do whatever you would want to do. Okay. Same way, integration, differentiation, all those things are directly supported in NumPy. Just to also talk about constants. For example, you would want to use multiple constants, correct? Uh, in your day-to-day calculations around uh, some calculation on scientific topics. For example, you want to calculate the weight of electron, or you want to use the weight of electron to do some scientific calculation. So all those constants are also present over here in NumPy library directly. So just to show that as well, just give me a second. Let's go to the user guide. Now, first thing, if you remember, I asked all of you to go through the documentation of Python, correct? That please go through the documentation of Python. It is very important. Now, is it necessary for you to go through the documentation of NumPy? The answer is no. Okay, the answer is no. You can completely skip this. It's not necessary. Just give me a second. I'm not sure if they updated the page. I was looking for constants and I'm not able to get all the constant values. That is what I was trying to do. There was a place where all the constants were there. I think this is, but this is not showing me all the constants. So infinity, it's showing me the Euler's constant. But again, it has all the constants of neutron weight, proton weight, Planck's constant, Avogadro's number. Everything is present in this library if you want to use them. However, they're also present in another library, SciPy library, but still, just to mention those things. So this library has support for all those things as well. Various CDs, various constants, everything is present over there. Okay, so this is the library I was talking about. Now let me move back to the. So is it clear first of all what we'll be using NumPy for? So any kind of calculations, linear algebra if you would want to do, we'll use this. Now please listen carefully. Going through the Python documentation is necessary. NumPy documentation is not necessary. Why so? Because we'll not be using NumPy directly a lot. You'll not be using NumPy directly a lot. Instead, the libraries that you'll be using a lot uses NumPy at the backend. For example, you will be using Pandas library a lot. That uses NumPy at the backend a lot. Okay. So your direct interaction with NumPy will be a bit limited, but the backend implementation, like the backend use of NumPy library among a lot of libraries is very common. Okay. For example, the algorithms that you'll be studying uses the concepts of linear algebra, uses the concepts of differentiation, integration. So those libraries at the backend will be using NumPy for doing all the calculation. But in your use, like what you will be doing, you won't be able to see that. Okay, like what is happening at the behind the scenes. You can have a look at that, but you'll not be the one interacting with it. If I want to put it in that way. Clear to everyone? Any questions? Any doubts? Okay, so now let's do one thing. So we have talked about NumPy, we have talked about when it is used, how commonly you will be using it, whether you need to go through the documentation or not. Now let's do one thing. Let's open up the code. Let's see how to import NumPy, and then what various functions in case if you'll be using, you'll be we'll be seeing those only. That what functions commonly you'll be using, and how to use those, how to use the NumPy library, and all the things around it. Okay, so perfect. So let me stop the share. Let me open up the Python code. Meanwhile, if you have any questions, please post your questions in the chat. Is my screen visible to everyone? The programming screen. Okay, so we already talked about how you need to install NumPy. Again, in case if you're using Anaconda or something else, it's already installed. Otherwise, in case if you want to install it, simply pip install NumPy. Now we have done the downloading, we have done the installation. Now, because I'll be using in this code, so I need to import it in this code. So how do I import it? First of all, look carefully. So this is first of all how I import NumPy in the code. Okay. How do I import it? Import NumPy, as simple as that. So you use the Python keyword import, import. This is how you import NumPy. Now this will give you an error in case if NumPy is not installed in plain sense, downloaded and installed in your system. Then it will give you an error. Okay. So once download and installation is complete, then this is how you import NumPy. Now the common name that we give to NumPy in the domain is NP. So you'll see a lot of codes where we say import NumPy as NP. So NP is simply a alias that we are giving to NumPy library. Why so? So that when I want to use NumPy library, for example, just to show you, I'll be using NumPy library to make arrays. Okay, just to show you more NumPy library to use some functions. So instead of writing NumPy everywhere, I'll be only writing two words, NP. So just to save us from pressing three keys multiple times again and again. So simply np dot this, np dot that. So np is kind of now referring to NumPy. So simply a nickname you can say kind of that we are giving to NumPy library while importing. Can you give any other name? Yes, you can. But np is the most common and widely accepted name across the domain. So import NumPy as np. Once you import, run this. Now NumPy is present in your this environment, this code. Okay, so certain information around NumPy now will be building on top of that only. Don't worry. Now the first thing is, now please listen carefully, everyone. Now in your Python, the default data containers or structures that we talked about were list, sets, tuples, and dictionaries. Correct? Now in NumPy, there is another data structure that we call as arrays. Okay, that we call as arrays or ND arrays. Okay, the official name is however is an ND array, but we also tend to give it a name or a nickname arrays basically. Now the first question, so if someone asks you is array a default Python data structure or data container, the answer is no. NumPy array is specific only to NumPy, means this data container, the NumPy array, is similar to what list tuples are. Like it also stores data. Okay, it also stores data, but it is only present in essence of NumPy. Like it's only in present with respect to NumPy. If NumPy is not there, you cannot have a NumPy array as well in plain sense. Okay, so it's a inbuilt data structure or data container of NumPy. We call it as a NumPy array or simply arrays or ND arrays. Okay. Now a NumPy array can be made from list, tuple, dictionary, sets, whatever you have, you can make a NumPy array from that. Now your question would be, why would I want to make it a NumPy array? Now two to three things. First thing, all the operations that NumPy does, for example, if you want to do linear algebra, Fourier transforms, integration, differentiation, NumPy mostly works with its arrays only. So you'll have to convert the data that you have in form of a list, tuple, sets, dictionaries, data frames, anyway. You'll have to convert it to a NumPy array for NumPy to do the calculations that you want NumPy to do first thing. That's why we have to convert data from list tuple to NumPy array. Okay. So how do we convert it? And now the question would be, why would it require us to convert the data? Because it works only with arrays, first of all. Second thing, arrays are much more faster compared to list and tuples. Now your question would be how? Because how the code has been written in NumPy backend, basically how the code has been developed in NumPy, that makes them faster compared to list and tuples. Because NumPy library has, as you were able to see, 30% of the NumPy library is written in C as well, correct? So C, C++, which are comparatively faster in execution than Python. So that is what makes them a bit fast compared to Python. Now coming to the next part. So how do we make NumPy arrays in Python? By simply using the code np.array, np.array, as you can see, open close small parenthesis, pass in the li, which is this particular list that we made over here, and this is how you make your numpy array. So this is how it looks. Now this is a container very much similar to your list, okay, but it's a numpy array. Now there is one more thing that you should know about numpy array is that it is only recommended, not a mandatory part, to keep similar data format in a array. Means example, because see, NumPy is a numerical mathematical calculation library, like it does all the numerical calculations. So can you do numerical calculations with strings? The answer is no, correct? So mostly we tend to, and every time we tend to do numerical calculations with numbers only. So it's always recommended that you only have numbers in a NumPy array. Do not use NumPy arrays for storing text or those things. It will not give you error. Okay, but essentially it will not be working as quick as how other things would be. Okay, so NumPy array is optimized for numbers, numerical calculations. So this is how we convert it to NumPy array. We have seen that. Now this is the output of Jupyter Notebook. Jupyter Notebook shows it in this way. Array. Now your question would be, why does it write array like this? So that you can distinguish between a list, because if array is not written, just assume if array is not written, it will completely look like a list and you will get confused. So Jupyter Notebook provides you this additional functionality of showing this array written in front of this thing. However, if you follow the default recommended method, like simply printing array, so this is how it looks. Now you'll see this is very much similar to a list. Correct? You'll see this is very much similar to a list. But the answer is to a certain extent, yes, but not completely. Just to show you what I'm saying, if I try to print list li, when you print list li, there will be commas, sorry, there will be commas as well. As you can see, commas are there, but in an array, you do not see those commas. In visual form, that is the difference. If you want to distinguish between a list and NumPy array, if it is printed as per the recommended method by Python, you will not see commas at all in an array, whereas in commas and list will be present. However, in case if you're using Jupyter Notebook output help itself, so it in fact shows the array over here. Yes, of course, if you use a type, we'll see that. Don't worry, we'll be coming to that part as well. But just because every time we'll not be saying a type. So you simply would want some visual cue as well. Like as soon as you see it, you know what it is. Okay. Same way, NumPy arrays can be made from tuples as well. So np.array and pass in the tuple tu, and it gets converted to the array. That is what you can see. Now, if you pass nested list into a array, if you pass a nested list, if you want to try to convert a nested list to an array, this is how it will look like. For example, this is my nested list, a list having multiple lists. If I convert this to an array, so this is how the array looks like. This is how the array looks like. Now this is an array. Please listen carefully. This is an array. It's not anything else. It is an array. But don't you think that it looks similar to a matrix? In view, it looks similar to a matrix. If you recall what matrices are, like 25, 65, 6, 8, 32, 26. Do you see that? It looks very much similar to a matrix. Correct? So if you pass in a data, if you pass in a nested data to a NumPy array, it is converted to an array only. It's an array only. Please remember that. Just the way it stores is it in form of a rows and column structure. Rows, like it stores in the form of two-dimensional data. Now please listen very much carefully. See, this data is one dimension data. When I say one dimension data, means you only have one stream of data. Your data is flowing through only one direction. Okay, like only horizontally data is present. Only horizontally data is present. But in this, data is present across two formats. One is vertically and one is horizontally. Correct? Like you can, if you want to go to any number, for example, let's say 8. So you'll say go to the second row and then the second column. Correct? Here like this. Do you agree? Like here the data is present simply across one axis, but here the data is present across two axes, vertical and horizontal. So this is a two-dimensional data now. Now your question would be, then what is three-dimensional? If there is something around like this as well, there is some depth as well. Okay. If there is some depth as well, then that becomes a three-dimensional data. And then now your question would be, what will be four-dimensional data look like? We cannot draw four-dimensional data as humans. We have that limitation. Directly, I cannot draw how four-dimensional data would look like, but it will be, let's say, somewhat parallel, like perpendicular to all the existing three dimensions. Getting it, everyone? What I'm trying to say, the concept of dimensions. So this is simply a nested list. It's one-dimensional data with respect to a Python list. But as you know, NumPy arrays are far capable. They're able to have information in forms of vector, all the mathematical terms. So as soon as you convert this into an array, NumPy stores it in form of dimensions. It gives this a rows and column structure. There are two dimensions now. Okay, there are two dimensions now. Hence it is a two-dimensional data. In case of 3D, it would be like this, and could be like this as well. Okay, so basically a box like this. So is it clear, anyone? Everyone? Does it make sense? What I'm trying to say? Correct, yes, totally correct, Toby. So you can say this is x-axis, or I can put this arrow down so that if this helps everyone to understand, I'm totally fine with that as well. So I can say this is how the data is now. X-axis and y-axis. And let me put this arrow in above, if that helps all of you. I'm fine with that as well. Does it make sense? Now data is present across two axes, x and y. Rows and then columns. And for 3D case, how it will look like? Or you can take it in this way if this is how you want to see XYZ. Does it make sense, everyone? Any questions? And when NumPy array stores the data in a form of two-dimensional structure, it looks very much similar to a matrix as well, correct? Like 25, 65. How many of you remember matrix? You might have studied this in senior secondary or during your graduation. Do you remember matrices? Now, most of you would be worried that, okay, now things are starting to get mathematical. Rahul has started writing equations, started making x, y dimensions, and started making matrices. So, will we learn mathematics a lot? The answer is yes. But will we do a PhD in mathematics? The answer is no. Just to put it very plainly and in simple terms, see all the algorithms in machine learning, deep learning, I told it in the first class itself, they are essentially mathematics at the end. Behind everything, whether it's physics, whether it's chemistry, whether it's biology, if you go deep down, ultimately at core of everything is mathematics. Okay, even the orientation of a flower, even the orientation of the eye structure of bees, anything. Everywhere mathematics is present. So same is the case over here as well. The whole machine learning, deep learning, and in fact in any programming language, ultimately it's one and zero only at the last part. Correct? So ultimately, what I'm trying to say that all the algorithms, everything to the core is maths only or stats. Stats is a branch of mathematics, however, but still it's math only. So we will be learning the things that are required for us to know the algorithm, and we will be drawing a line also that okay, this is still where we should know. Otherwise, again, math is a whole field in itself. You can keep on evolving and understanding, and as you go in research, and it's never ending. But we'll learn only what is required. We'll not try to do a PhD. We'll try to learn and get the essence of okay how things are working mathematically behind it. Getting it? Why so? Now the question would be why would you do that? Because that is what you should know for you to use a algorithm properly. You should know how it works. Okay. If you, let's say, if you are the one, if you are the captain of ship, you should know what this particular let's say display is telling you, what this particular radar is telling you. Okay, I cannot simply say that okay, this is a ship, drive it. You will be able to drive it, but you will be ultimately crashing it as well. So same is the case with machine learning and deep learning algorithms. For you to use them, you should also know how they work, what parameter I set, how will it affect the performance of my algorithm. Okay, so we'll be going through a lot of maths, a lot of stats, but I'll make it in such a way that we go slowly and steadily, not suddenly that in today's class only I'm talking about partial differentiation. No, I'll not do that. I'll start taking things slowly and steadily till deep learning is when the whole mathematical concepts will be mature enough to discuss completely. But yes, just to give you a heads up there, and again, there is a prerequisite course of maths and stats in your self in your LMS portal, so you can go through that as well. In fact, okay, it would be recommended for all of you to go through that. Any questions, anyone? Don't be afraid. I hope I'm a good teacher. I'll be teaching all the things clearly and easily. It's not required. If you have gone through prerequisite, fine. If not, you can go through that, but still I'll be covering things from the basic only, like how I cover for all the things. And I hope all of you understand that. It's not that I simply say. Right. Please give me a few seconds. Okay. So coming back to the topic, so this is how the data is stored. Uh, this is how NumPy stores data of nested list. It stores the data in a form of a two-dimensional data, which has rows and columns, very much similar to how your matrix looks. Okay, it is still a NumPy array. It's not a matrix. Do not go into that part. It is an array as a data type, but it is what it is doing. It looks like a matrix. That is the only thing that I'm trying to say. Why so? Because it stores the data into two dimensions. Now, if you look closely, now your question would be okay that NumPy library is there. Will it work with my default Python functions? Now see, NumPy is a library written in Python, correct? So does it work with the Python code, like your Python functions or your built-in Python functions? The answer is yes, it will. Does it work with for loop? Will it work with while loop? The answer is yes, it will. Okay, because it still has to follow the normal Python built-in rules as well. Okay, it's not a separate environment. It's a library written in Python itself. For example, I printed this array. Was this print like this is a array, NumPy array, correct? I printed it. So print is a Python built-in function. Did it run? Yes, it ran. It ran. Same way, if I say type matrix, I simply this is the name of the variable. Do not think this is a matrix. This is an array only. If I say type mat, I run this. See, this is also working. It tells me that okay, this is a NumPy ND array. What is the use, sir? Here array. Which use? Or uses of array? That is what you're asking, Roshni. We talked about that. No, in case if you want to do, if you want to use NumPy for doing something, you'll have to convert data into NumPy array. For example, you want to do matrix multiplication, so you'll have to write your own code. But in NumPy, there is a already function for matrix multiplication. But for you to use that, you'll have to convert the data to a array. Okay. Does it make sense? Also, let's say, as I mentioned, NumPy is very quick in doing mathematical calculations. It has a lot of mathematical tools as well. When I say tools, that for you to simply do transforms and XYZ things. So simply you'll have to convert the data to array and you can do whatever you want to do, whatever mathematical calculation you would want to do. Okay, perfect. Now moving ahead. Now how can we check the dimensions of an array? By simply using mat.ndim. Ndim stands for what is the dimension of this variable. So mat is simply what? Mat is simply the array name, like the variable name. So I say mat.ndim, and what is mat? Mat is a numpy array. Dot ndim, so it says this is having two dimensions. This is having two dimensions. Now you might want to see that, okay, how do I know how many number of elements are present? By simply saying mat.size. Now these are the built-in functions present with numpy arrays, and these are numpy array specific functions. Means, can you say a list.ndim? No, it will not work. It will give you an error. Can you say a list.size? No, it will not work. It will give you an error. Okay. So what does it do then? These are functions associated with numpy array only. Okay. So mat is what? Mat is a numpy array. So if you say mat.ndim, it gives you the dimensions. Mat.size, it gives you the number of elements present in your array. Mat.dtype, what is the data type of these? It tells you that this is integer 32. What is 32? We'll talk about that. Don't worry. We'll talk about those things in detail, integer 8, integer 32. But as of now, in plain sense, it's an integer. Okay. Integer is a data type. Clear, everyone? Okay. Same way, if you want to check the shape, for example, we know that, okay, it's a two-dimensional array. Now I want to see that, okay, how many dimensions are there? Sorry, how many rows and columns are there? So when you say mat.shape or numpy array.shape, this tells you the number of rows and columns. Always remember, the first number indicates rows, always, and second will indicate columns. So it says that this particular array has 3 rows and 2 columns. If you remember in matrix, we used to write m cross n. Do you remember this? And what this m cross n would refer to? Can anyone tell? Correct. Rows and columns. Correct. So that is what these things are over here as well. You can call this m and n or whatever thing you would want to call. So this also indicates the number of rows and columns. And now the data is stored in form of matrix. So I can do all the matrix operations. Now, so many of you might have a question, why do we use matrices? Now that's a mathematical question, essentially, that why do we have matrix? In plain sense, let's say you want to do linear algebra calculations or a lot of data. So without matrix also you can do it. But when you use matrix, your calculations are much simpler, much faster, even when you're doing it by hand. Okay, so matrix calculations, matrix helps you to do various calculations much more quickly than simply trying to solve them one by one. In plain sense, that is the use of matrix. So matrix helps you to structure data in a form, in a tabular kind of form, and helps you to solve various problems in a single go and very quickly. And complex problems as well with respect to vectors, getting the shape, or you can say direction in which the vector is pointing. So all those things can be very easily done with matrix form of data. What is a matrix? Your revision around that. Just give. It is like this: rows, and then there are columns. It can have n number of rows and number of columns. Okay, but if rows and columns are equal, like 2 rows, 2 columns, we call this a square matrix. Square matrix. If there is a matrix in which all the things are 0, but only diagonals are 1, 1. We call this as identity matrix. Okay, identity matrix. Like there are various terms. Matrix is a whole concept in mathematics itself. But in plain sense, matrix is a form that allows you to store data in form of rows and columns and allows you to quickly do a lot of calculations with a lot of data quickly rather than trying to solve it one by one. Okay, now let's stop over here. Let's first of all take a break. Post the break, we'll continue. So let me first of all launch the pool. Meanwhile, all of you can poll. And then I'll share the screen with timer and we'll go for a break. Okay, I hope everyone has polled. So I'm ending the poll, sharing the screen with the timer. Let's go for a break and see you after the break, everyone. Please give me a few seconds before I launch a timer. So is the timer visible to everyone? Thank you, everyone. Going for a break. See you after the break. Thank you. So is everyone back? Okay, so let me share the screen. Let's continue with where we left off. Any questions, anyone so far? So let me share the screen. So I hope my screen is visible. Okay, so we talked about matrix shape as well. Okay, like what does it do? It gives us the number of rows and columns present in the data. That is what it does. Now we'll move on top of it only. We'll talk about various built-in methods in NumPy array. When I say built-in methods, means if you simply use np the NumPy and simply say dot arange or these things, it will give you certain outputs that you would want to use. Okay, so let's go into the first one. So how many of you remember the Python range function? Do you remember the Python range function? So this is completely similar to that. So np.arange is similar to Python range function. The difference is first that it's not a generator, means it will give you data directly when you ping it. Second difference is the major difference that Python range function does not work with float values. Okay, Python range function does not work with float values, whereas NumPy arange function works with float values as well. For example, so this is first of all, let's see how we write this code, very much similar to Python range. So np stands for NumPy dot arange, and I'm saying 0 to 10. Again, start stop, and there is a step size as well. Once I do this, so it gives me a NumPy array with all these numbers. But the interesting thing is that it does support in float values as well. Okay, whereas range only supports integers. So you can see that I want to start from 0.5, go all the way till 30.5 with a step size of 0.36 or 0.3, whatever steps you want to take. And if you run that, it will be showing you that now. So it will generate that data with that number of steps in float values as well, which is not possible with range function. So now if you want to generate some interval data with respect to float values or decimal values, that is easily possible. For this, otherwise you'll have to write a code to add 0.5 or those kind of values. So this directly gives you a range, and you can kind of go into n steps. For example, if I say 0.00003 like this, so it creates a lot of objects now, as you can see. So very small additions tend to happen now. So select, for example, 0.5356 and see how many data points have been created. You see that? So that is how you can use this. Okay, so NumPy arange function. Now, NumPy also has a module known as random. Okay, so this helps you to generate random values, random integers for some purpose. In case if you want to generate some random data, you can do that with NumPy. However, just to give you a mention that there is a random library as well, a completely separate individual library, random. Name is itself random. So if you do import random, you can use that library and talk about that things as well. As you know, there are approximately 600k libraries in Python. So there are many libraries. One of them is random as well, and NumPy is also one of them. So let's see certain functions how you can generate random data using NumPy. So np.random is a module in which using which you can generate random data. Now inside this random module, there are further functions that help you to generate data. For example, np.random.rand init, RANDINT. You say 1 till 40, like you're saying that, okay, from 1 till 40, generate a random number. This number is exclusive. Exclusive means the random number will never be 40 and at any point in the time. Okay, whereas the lower number is inclusive, means it will be there. Once you run this 18, now you can generate these numbers. If you try to think about a use case for doing lottery generation or for doing authentication, for example, if you try to log in into some accounts which has multi-factor authentication, and then it would send a OTP at your device using various apps or XYZ things. So you can kind of relate it with this as well. Just to show a diagram around it, for example, for someone who's completely new, just say if I try to make a flow, for example, let's see. So what happens is, let's say this is, and what I'll do, let me zoom in a bit. Okay, let's use this only. For example, let's say this is a website. Okay, and there is this login page over here. You pass in your username and password, and then it will simply open up a box for mentioning the OTP that you received. Correct? But how is that OTP sent? Usually, it will have a backend. Okay, usually it will be connected to a code, could be written in any language. Let's say for our case, it is Python. Okay, so what will Python do? Python will simply, let's say for our case, nb.random.randinit, the function we talked about, let's say 0 to 100, some random number between this. So let's say it generates 99. Now this number is related to your mobile app. Okay, let's say if you're using a mobile app, and it is also related to the front end that okay, this is a OTP that the user need to put, or not necessary. It could be a double factor authentication as well. You receive this and you put it over here. Either it is matched over here, or it again sends it. Okay, this is what I've got. Does it match? If yes, the user is able to log in. So this is how the authentication in a broader view works essentially. But yes. So see, these random number generations can be done using rand init as well. You can generate n number of length of these random numbers. For example, from 1 to 40, just 18 length. I want to generate a 6-digit number. So a minimum 6-digit and a 7-digit number. Minimum 7-digit number. Once you run this, so any number that you will generate will be a random 6-digit number. As you can see, every time it is different. Can they repeat? The answer is yes, they can. Okay. Now, it could be that you want to generate a lot of random numbers in a single go. Is that possible? The answer is yes. For example, you are saying np.random.randinit 1 till 4000, and I want 10 numbers. So once you run this, it will keep on generating random numbers, as you can see. Also, I'm just trying to show you that random is a module. Inside this random module, there are so many other functions as well, if you see. So we are just talking about the rand init function, but there are many more things that you can see are present inside this. Like rand init is one we are talking about, random integers. There are many more functions. Okay, but will you be using them very commonly? The answer is no. For example, if you want to generate data around some standard normal distribution randomly, you use standard normal. If you want to generate data around hypergeometric probability distribution, you'll use this. Okay, so this is how it looks. Okay, visible, Roshni? Now, if you want to structure this in form of rows and columns, you can do that as well. Okay, so this is a random module which you can generate data around data around probability distributions, data around some integers, data around many more things in a form of random order. Okay, so you can generate data in form of a two-dimensional data as well. Like you're specifying, I want 5 rows and 2 columns, so you can do that as well. Okay, now the question comes, can you reshape your array as well? For example, you told that okay, I can do this thing, but what if I have a one-dimensional array? Can I reshape this in a two-dimensional array format? The answer is yes. For example, let's generate an array. So ARR from 0 to 9, or you can say from 10 to 20, or some number 56 to, let's say, 156 to 166. Sorry. Okay. So I have some numbers. Now, can I arrange it in form of 5 comma 2? The answer is yes. So 5 rows and 2 columns. You can see that. So this dot reshape function helps you to reshape your single dimensional array to multiple dimensions. Now your question would be, when I would do that? It depends upon what you are trying to solve. Correct? It's not always that you'll do this. For example, you have a data, it's across a single axis. You want to simply make it across two axes, you'll do this. If I speak more technically, for example, in convolutional neural networks, which we'll be studying in deep learning, for long short-term memory neural networks, which we'll be studying in deep learning, we'll have to reshape your data into four-dimensional arrays. Okay, so that is where this reshape function will come in handy. Just to relate with everyone, because most of you would be thinking that why we are learning NumPy, why we are learning Python. I already gave a brief around this on in the Python course itself, but just to give you a brief again over here now. See, currently what we are doing is we are learning the building blocks. I know all of you would be excited to see how machine learning actually works, all the algorithms they work. But when we would implement them, we would be using these functions. For example, convolutional neural network. This is an algorithm that works with images, identifying faces, identifying movements of people. Okay, this is an algorithm basically. This is what this algorithm does. But this algorithm requires data in a particular dimension, four-dimensional data. What is that four-dimension represent? We'll talk about that when we'll be there, over there in that particular class. But all these things which you are currently studying are the initial mathematical, like plus minus subtraction thing, kind of things that you are learning, which the brief that I gave in the Python class as well. These might be a bit boring as of now, but these things will all come together. So all the courses present in your this program are sequential in nature. So the contents that you're learning in this course will be for sure useful in your next course. The contents that you will be learning in next course will be for sure along with this course as well. Like all the contents that you'll be learning till next course, they will be coming in handy in the deep learning course. So all things are sequential in nature over here. They're not parallel. So it's not that you can start going through deep learning classes as it is just right now. The answer is no, you cannot. Getting it what I'm trying to say. So currently we're learning the building blocks because we'll have to reshape the data to feed it to algorithms so that the algorithm can give us the output. Okay. Same way we'll have to transpose the data. Like this is how we transpose the data sometimes for the algorithm to take it in and give us output. We'll have to flatten the arrays as well. Getting it? Why we are learning all these things from scratch. Now, if I talk from a bird eye view, if you are in a management role, if you are one who has more than 10, 15, 20 years of experience, of course, you'll not be programming this stuff. In that case, you can ignore this completely because you'll not be one who will be writing the codes. But for anyone who is completely new and will be programming in the role, if that is the intention for switching the domain, then you will be, of course, you all, of course, need to learn these things. Because then for every algorithm, there are two parts: theoretical part, the mathematical things that we'll be learning, and then the implementation part. How do you run that algorithm? How do you write and use that algorithm in Python? Like how do you feed the live data to it and get the outputs? For example, ChatGPT. It's also algorithm based on deep learning neural networks. So there is a data that goes inside it and it is able to think and give you output. Does it make sense, everyone? So all these things that we are learning are completely currently very basic, but all these things are handy. All these things will be useful when you'll be learning the things that you are here for. Questions, anyone? So this reshaping currently would not make sense that what we are doing, why we are doing this. But in deep learning, when you will be reshaping the data for convolutional neural networks, long short-term memory neural networks, transformers, then is when you'll be thinking, oh, it totally leads to the second course, first class. Getting it, everyone? What I'm trying to say. So if you are getting bored in this, so you'll have to stay uh, a bit active on that part. But again, all these things will come in handy for sure. Of course, I'll be sharing files as well as notes. or Toby, everything will be shared. Even the Blackboard notes also on your LMS portal. By today only I'll be sharing it. It's not that I'll be sharing it in next class. Today only I'll share it. Not an issue. Okay, so let's move ahead now. Okay, so this is how you reshape your array. Okay. Now, for example, I'm having this kind of array, which is 2 rows and 5 columns. Now, my first question is, let's say this is array having 10 elements. Can I reshape this array in 3 columns and 10 rows? What do you think? Correct. It's not possible. It will give you error. Okay. Why is it not possible? Because if I say 3 columns and 10 rows, so number of elements would be 30. 3 cross 10, 30. But how many elements do we have? We only have 10 elements. So Python will give you error that only 10 elements can be not restructured into 3 cross 10. So it's always a combination of the multiples. For example, 10 rows, so 2 cross 5, 2 rows, 5 columns, 5 cross 2, 5 rows, 2 columns, 10 cross 1, 10 rows, 1 column, 1 cross 10, 1 row, 10 columns. Okay. So it will be always in this form. So as I'm showing you over here, 2 cross 5, same way, 10 cross 1, 10 rows, 1 column. Do you see this, how it looks? Same way, 1 cross 10, 1 row and 10 columns. Now you might say this is very much similar to one dimensional. It is one dimensional data. The answer is no. Now let's talk about one more thing which will be helpful for all. Now, how do you visually figure out if it's one dimensional or two dimensional or three dimensional? If you zoom in, if you look closely, you simply count the number of square brackets. The number of square brackets is equal to the number of dimensions your array is in. Okay. For example, this is a single dimensional array, correct? Whereas this is a two dimensional array, means it is having rows and columns. For example, if I say 10 cross 1, do you see the number of brackets? 2. So it's a two dimensional array. Otherwise, of course, you can directly use the ndim function as well, which we talked about. So dot ndim, this gives you the number of dimensions of your array. But in case if you don't want to have a visual cue about how much dimensions there are, simply count the number of square brackets at starting of your array. That will give you an idea about how many dimensions your data is in. Clear, everyone? Okay, let's move ahead. Now, same way, if I say np.arange 30, so you can see I get 30 data points. Same way, I can reshape this into 10 cross 3, means 10 rows, 3 columns. 3 cross 10, 3 rows, 10 columns. Okay, 15 cross 2, 2 cross 15, 30 cross 1, 1 cross 30. So all the possible combinations. You can do that. Now, if you want to transpose your array, means making your rows as columns and columns as rows, you can simply use the dot t parameter. Dot t for transposing. Your rows becomes columns. As you can see, like this column was there, it has become a row now, and the rows are now the column 0, 1, 2, 3, 4, 5. Okay. Now your question would be, what if I use length parameter on top of it? Will it give me the total number of elements present in this array? The answer is no. For a two-dimensional data, for a two-dimensional array, the length function works with it. It does not give you error, but it will give you a wrong answer. It will give you a wrong output. Okay. So you should instead use the dot size parameter that we talked about to get the total number of values present in this array. Clear, everyone? Now let's do one thing. Let me share this code with everyone because you have talked a lot about it. And I want every one of you to go through this code, try to see how it is working, feel comfortable with it, try to generate summaries, try to do all the functions that we have talked about, look into many more functions as well by pressing tab and seeing what all functions it has, so that all of you get comfortable with it. And then once you are comfortable, we'll move ahead. So does len array the yes, in two-dimensional case, that is what it will be returning, Sudesh. But it will, I'd never recommend using uh, the length to figure out the number of objects present. In case if you want to figure out how many columns are present, use dot shape. That is much more consistent even than length. Okay, so let me share this code as of now in the chat for everyone so that you can go through this. So I've shared the code in chat with everyone. So please go through the code till the point we have covered, till the flattened part, and give me a thumbs up once you are comfortable, you have played around, you have looked into all the functions that you want to explore with it. Okay. Once you're comfortable, give a thumbs up, write done in the chat, and then we'll move ahead with the further topics. Because I do not want to simply keep on talking in case if you're not able to see how things are working, how they're getting used. Okay. Is the task clear to everyone? Okay, perfect. Thank you.
Jim using Jupyter Notebook. In case if you're using Simplilearn Labs, simply upload the file on Simplilearn Labs and use it. In case if you are using Jupyter Notebook locally, simply open Jupyter Notebook, browse to this file, double click on it, it will open. In case if you are using Visual Studio, again you'll have to browse to the file, double click on it, and it will open. But you'll have to have a Jupyter Notebook installation or notebook support on VS Studio, VS Code, sorry. Okay. We talked about this in detail in first course. So if you were present in first course, we talked about this in detail. Yugender will have to install NumPy. So please install NumPy, pip install NumPy. That is what the error states if you read the error. Rahul, simply go to the command prompt or Anaconda prompt and simply write pip install NumPy. You do not need to go to any website. It will be automatically able to go and install. Yugender, put a exclamation mark before pip in case if you're installing it using Jupyter Lab. Okay. Or else please go to Anaconda prompt if you're using Anaconda. Or in case if you're using any third environment, you can go to command prompt and write pip install NumPy. It will install NumPy. Yugender. First of all, installation should be always done using a terminal or command prompt. So you're using Jupyter Lab, it's a IDE. That is what I'm saying. Go to the terminal or go to the command prompt or Anaconda prompt and then write pip install numpy. That is what is a preferred method. Even in Visual Studio, go to the terminal in Visual Studio, and that is where you should write pip install numpy. And in case if you want to install it from the cell itself, so write exclamation mark and then pip install numpy. So it is present. You can it says that it is present. Pip numpy is already present in your packages. So you'll not get that error. You need to first of all then run the import command and see if it's working now. And I hope you're also connecting it to the Anaconda base environment when you are opening the file in Jupyter Notebook or Lab. It is connected to Anaconda environment. However, by default, it gets connected to environment, but you need to check that as well. In case if not, you have to connect it. Can you share your screen, Yoginder? Okay, first question. I hope you already have gone through the videos of Jupyter Lab or Jupyter Notebook, how to use those. So what I'm hoping is you're well versed with those things, and now then we can look into your error, because I'm not hoping you're conducting any a basic mistake. Okay, so please give me a second. So please share your screen if you want to. Let me also unmute you. Yes, Yoginder.
Yeah, the screen is visible.
Yes, it's visible. Run this command first. Let's pip install numpy here itself. Run this command. You need to put exclamation mark.
Before P.
Yes, before pip. It's a markdown cell. Convert it to a code cell.
Sorry,
Go to the pip install numpy cell
this one.
and convert it to the code cell. Okay. Do you see that markdown option written over there? Just below your numpy.ip nub name tab. No, do not close this. Just below this, can you see this markdown written?
Yes.
Click on this, click on code, run this. Wait
Yes.
a
Now
second,
it's
it's currently executing.
okay. Thank you, Rahul.
Wait, it's not installed yet, Yoginder. Now it's installed. Now try to import. Yes, it's imported. Now if you run it, it will not give you any error. Okay,
Okay.
thank you.
Thank you.
You can stop the share. So has everyone gone through the code? Okay, so let's continue with where we left off and cover the other things. So I hope now everyone feels comfortable with NumPy. They are able to install NumPy. If it was not installed, they're able to understand the codes, make arrays, and see all the functions, how they work, and explore a bit more on top of that. Now let me share the screen. Let's continue and let's talk about the flatten part and further on. So I hope my screen is visible to everyone. Okay, so you're on the flatten part. Now what is flatten of array? For example, if you have a multi-dimensional array, give me a second. Okay, so if you have a multi-dimensional array, you would want to make it single dimensional as well. Just simply flattening it. So how would you do that? By using the dot flatten function, okay, or the dot reveal function. Both of them do the same thing. Let's say we have a numpy array. I'm saying that okay, there will be some random numbers between 1 to 400, 3 rows, 5 columns. That is how it looks. So when I say arr dot flatten, arr dot flatten, it simply flattens the array. Like it converts it to a one-dimensional array. That's it. Okay. Now if you see dot arr1 dot shape, so it says 15 comma. Now what does this indicate? It indicates that this array is one-dimensional and there are 15 elements present in this array now. Okay, because it does not show any column names, it's only telling you that it's one-dimensional array now. Okay, and now in one-dimensional array, when you run length of arr1, you can see that it is very much similar. And again, if you see d type, so it tells you data type integer 32. Now let's talk about what this data type is also as well. Okay, what this data type is as well. Bharat, I did not get your question. Is that a question? Bharat, is it a question? Okay, okay. That was a statement then. Okay. So now talking about what this integer 32 and what these things are. Okay. So in plain sense, they represent the bit. For example, this integer 32, 32 represents the bit of this integer. Okay, what is bit in plain sense? Like how much information this integer can retain. That is how you can try to think of it. So there are different types of integer. Let me open that code up, please. Just give me a second. I have the range and all this information in another code. Just give me a second. Is my screen visible? So these 8, 16, 32, 64, these are the bits of integer. In plain sense, you can think of them as how much values or range of numbers they can store. Like what will be the storage size? 8-bit, smallest storage size. 16-bit, a bit high. 32 highest. 64 is the highest. Okay, so this is, you can, in terms of storage, you can say that this is the storage size. Or in terms of precision and range, this again, because higher the storage size, more the number of numbers it can retain. Without talking too much, just let's move into the range part, just to show what this number is showing you, what this information is showing you over here. First of all, I've simply written a for loop. over this integer 8, 16, 32, 64, showing what is the minimum number it can carry or store inside it, and what is the maximum number it can carry. So integer 8 it only has range of -128 to 127. Means if there is some number 356 and you convert it to integer 8, can it store that? The answer is no. Integer 8 can only store values can only represent integers between -127 to -128 to 127. Okay, it can only show these integers. Like if you are having a number between this range, integer 8 can work. Now, if you are having integer 32, as you can see, the range goes till -32,000 to +32,000. Now, when you go to integer 32, the range goes much more higher. And for integer 64, you can see that how big these numbers are allowed now. Okay. So more than some trillion or zillion numbers, in fact. So this is how long the numbers are allowed for integer 64. Yeah. Now same goes with float as well. So you have float 16, float 32, float 64. Now you'll say that, okay, what does float refer then? In float, see, there are numbers after decimal. And when, let's say, if you're adding 2, 3 numbers, it depends, the precision totally depends upon what decimal place addition you are doing. If you're only doing 2 decimal place addition, so it's simply a 2 decimal numbers that will be presented. But if, let's say, you're adding trillions of numbers which are having float values, just even having a different 4th digit number place will be simply moving the results up and down. And you would agree with me on that part, correct? A slight change in even in the 4th decimal place for a trillion calculations will change the value. So you would want a high precision. So float 16 only supports 1 decimal value. Float 32 supports more than 38 decimal values. And float 64 supports more than 308 decimal values. Do you see that? So this simply shows you, because now see it can store so many decimal values. So of course float 64 will be a bit heavy in storage. Okay, means it will occupy much more space in your memory, but still the precision will be also higher. This is simply a for loop, and for loop I am simply saying dot info dot minimum. These are the numpy functions for getting the minimum and maximum before. For loop, we have already gone through how for loop works. So inside the for loop, I'm simply printing the minimum and maximum using the numpy function. That's it. So is the concept of integer 8, integer 16, 32, 50, 64 clear to everyone? Okay. So let's move to the another parts now. Now, NumPy also has built-in functions, NumPy built-in functions for getting the maximum, minimum values as well. For example, let's say you have an array. I'm simply writing a random array, 0 to 50, 10 digits. So these are some random numbers that I get. Now, when I say ran arr dot max, so it tells me what is the maximum, like this dot max, what is the maximum number present in your NumPy array. Now you might have a question, can I use the max Python built-in function as well, like this max Python built-in function and pass in this? Will it also work? The answer is yes, it will also work. But what additional thing it has is NumPy, it has a argument dot argmax. What does this give? It gives you the index value. It gives you the index value of the number which is having the maximum value. It gives you the index position of max, the highest number basically. Let me repeat, it gives you the index value of the highest number. That's it. So dot argmax, it says that okay, it is present at the 6th index. So if you see, highest number in our case is 38, which is present at the 6th index. So that is what this represents. Same way, dot min gives you the minimum value. Argmin simply gives you the index of the minimum value in your array. Okay. Now let's jump into indexing and selection. Now in NumPy, the concept of indexing and selection remains exactly the same how it was in list and tuples. We tend to use square brackets, and it is consistent across all the libraries. In fact, the concept of indexing is consistent across pandas as well. Everywhere, if you want to index, you'll have to use square brackets. Follow, of course, the name of, or you can say the variable name representing the iterable or data container. The data container itself, followed by the square brackets, and followed by the values inside those square brackets. So let's say I'm having some array, 38, 43, some array I'm having. Now, how do I index? How do I extract the elements using index values? Exactly same. In NumPy array also, the index starts from 0 all the way till n, and this is consistent across Python. It also supports negative index. From back, it starts from -1 all the way till the first value with negative indexes. So how does it run? ARR 8, if I run this, you can see it shows me 18. ARR -1, it does that as well. It even supports the step as well. So ARR 1 colon 5 colon 2, it tells me that okay, it will start from 1, go all the way till fourth index. Means last index is still not included over here. Last index is not included over here. Keep that in mind. And then step size of 2. Hence you get only 43 and 31. This one. Okay, so that is what is happening. And same way, colon 5 till the fourth index. So indexing is exactly same to what you have learned in list, tuples, and all those things with arrays as well. Okay. Now let's move into the concept of updating the arrays. Arrays are mutable, like list. Means you can add elements into arrays, you can change elements of arrays, you can remove elements of arrays from arrays. You can do all those things with arrays as well. So arrays are mutable. Okay. So how do they work? Let's see that. Let's say this is my array. Okay, and I say ARR square bracket 6. So this tells me that at sixth index, the element that is present is 17. Now what if I say ARR square bracket 6 is equal to 1? Will it update the 17, replace the 17? As you can see, the answer is yes. Can I do this thing with tuples? What do you think? Can you answer that? Can I do this thing with tuples, everyone? The answer is no. Tuples are immutable. You will get the error. It's not possible. Correct. Same way, now there is some additional thing that you can do over here. For example, if I say ARR 0 colon 5, so I'll get all the elements from 0th index till 4th index. Last index is never included. Keep this in mind. Repeating multiple times. So now if I say ARR 0 colon 5 and you say equal to 100. Now what happens is all the numbers, all the index values are given as 100. Means it allows you to mass update a batch update of index values as well. And NumPy allows you to update batch indexes as well. Okay, like a lot of index values in a single go. This is not possible with list, and tuple does not support at all any kind of mutable object things. Okay, so this is one of the good part as well. Now your question would be, does NumPy array also follow the concept of auto-aliasing? Do you remember the concept of auto-aliasing? Like if I simply say A is equal to a list which is already defined, and I change elements into A, so B also gets affected. How to avoid this? By using dot copy. Do you remember that? We talked about this in a Python class. So that is what exactly happens over here. So I'm generating an array with 0 till 14. And if I say error 0 colon 6, like this gives me till 5th index now. And I store this inside a variable, let's say slice of ARR. And now if I update this slice of ARR variable only, like all the index to 56, will this affect my original array? The answer is yes. Okay. So this is my ARR originally. I extracted 0 till 5th index from this array, stored this into slice of ARR variable, and post that when I assign 56 to all these values, even my original array is having those values. This is the common thing that happens across Python. In list, also in pandas, data frame, we'll be seeing that. So it happens nearly everywhere. Okay. So how do we avoid this? By using the dot copy functionality. Okay. So array also has the dot copy function. Okay. So you can see that now my array does not get affected at all. Perfect. Now let's see how you can do indexing with two-dimensional arrays. We were able to see that okay, how does indexing work with one-dimensional array, but how does it work with two-dimensional arrays? Let's see that. So let's make an array. So this is how a two-dimensional array looks like. Okay, we have seen this multiple times. Now, how do we index on top of this? So it's very much similar to how nesting indexing was done on nested list. For example, if you say ARR2D, this is the name of the array, and you put in square bracket, so you're doing indexing 1, so it will give you the row. Always remember, anything will first refer to rows. Now please listen carefully, everyone. So for a two-dimensional array, also the index starts from like this is the zeroth index row, first index row, sorry, first index row, second index row. And same is the case with columns. Zeroth index column, okay, first index column, and second index column. So what happens is that index for both rows and columns starts from 0, exactly how it starts in Python. So index starts from 0. Now when you say ARR 2D1, so the first number will always represent the row. So you can see when I say this, and just if I run this code because it is a random array, you can see that it returns you the, look, it's not a random array, sorry, my bad. It returns you this first row. Okay. Same way, now how this index is written, please listen carefully. This is first of all how the index is always written. ARR2D first index will always refer to row, second is column. For example, I'm saying 0th row and 0th column. So 0th row is which one? Just let me first of all erase these things. So if I say 0th row, what is the 0th row? This one, correct? And then second one is 0th column in this row. So in 0th row in this column is, 0th column in this row is this 78. So it gives you 78 as output. However, NumPy also allows you to do indexing using this format, which is much more convenient and easy to see. So let's look at many more examples after this. For example, and let me zoom out a bit, sorry. What if instead of writing 0 in square bracket, then again 1 square bracket and 0, what if I write like this? So this will also work and giving you this 78. Okay. If I say first row, second column, so will it work? The answer is yes, it will also work. So what is the first row? Let's see that. So 1, it says that, okay, this row. Okay. Then you are saying in this second column. So like this is what you are saying. So this common area, like this one, is given as output over here. Oh, sorry, the second column, not the first column. So this 2 says that you want second column. So this is a 0th column, this is the first column, and this is the second column. So you're selecting this second column. So you said that first row and second column. So only this area is selected, correct? This is what is common. Hence, this is given as a output over here. Hence, this is given as a output over here. Does it make sense, everyone? That is how it works. Let's look at more examples. So this is our array. Okay. Now I'm saying that ARR, and always remember, first index refers to, so variable, first index will always refer to rows, comma, columns. Second index to columns. Now I'm saying, please look carefully. Now I'm saying that give me all the arrays till second row. So what are the rows that I have? Let's write the index first so that it is clear. So this is 0th row, first row, second row, correct? Index wise. And if I use for columns, so this is the 0th column, first column, second column. Let me use some dark color, just give me a second. Or some bright color. So 0th, first, and second column. Okay. Now what is this particular part saying? That all the rows till second row, last index is never included. Correct? So if I see this, what does it do? So it goes all the rows till second column, like till second row, sorry, all the rows. That is what it selects, first of all. Okay, this is what it selects. Now the second part says all the columns from first column, all the columns from first column. So what does this do? So column 1 and all of them thereafter. Like this is, and this is the common area now, correct? This is the common area now. And this is given to you as an output over here. So does it make sense to everyone? How things are working over here? Toby, what happens is, if I try to erase this, just to bring in, give me a second. See what is happening over here. So I'm saying that from, like at this laser point, so I'm saying till, because see what is the syntax? The variable name followed by rows followed by columns, correct? Rows and columns. So what this indicates? So it says that this is indicating first of all to rows. So all the way till second rows. Now what are the index? So this row, this first row is having 0th index. Then this row is having first index. This third row is having second index, correct? So I'm saying all the way till second row. Okay. So what happens is, just to show, so it says only this much, like only these two rows. Okay. That is what it indicates. And then I'm saying for columns from first column all the way till last. So then it says that, okay, this column. Okay. So it is a common area now, this part. Getting it? So that is what happens. Just to repeat. So this indicates these two rows, correct? This indicates from first column all the way till last column. So this is the 0th column, correct? This is first, this is second. So from first column all the way till last, correct? So it is a common area now. this part, and this is what is given as a output over here. Does it make sense now, Toby? Sure, let me unmute you. Yes, Toby.
Yeah, what I'm trying to understand is because if you are picking from for the rows, you are picking from the index number 0, because if you said from 2, let's column from 2, so it should be from the second to the from, let's say, line from 25.1 to 23 to 9.4.21. So why you're picking from 78, 97, 24 to 25.1 to for the rows is what I don't understand. That is
Okay,
what
first of all, see, let's go step by step. Just give me a second, and keep yourself unmuted. So see, do we agree that these are the rows? First of all, these are rows, correct? And these are columns. We both agree to this. Now, first of all, the colon is before, so it says that 0, 1, 2. So if I want like these to indicate, I'll say colon 2. Means 2 will not be included, but this particular syntax says that 0th and first row will be included. Okay, but what you are saying is if I say 2 and colon, so then it says 0, 1, 2, and let's say 3, 4, all the way till n. So this syntax says from 2 all the way till n. So where you are putting colon determines what rows we'll get. So here I've said colon 2 means all the rows till second index row. So 0th row, first row. Both these rows are, let's say, selected just with this particular code. Okay, colon 2. Let me remove these things now. Just give me a second. Now, what we are doing is we are saying that, okay, from first column, now this column is at the back, means from first column all the way till n. So what are the columns? 0, 1, 2. So from first column all the way till end, like all the way till end, if there is any end. But however, in our case, only these two are the cases. So this particular one selects this. But now both the indexes are together. So only the common area is given over here. Okay. So I hope it's clear now. Because the output has to take care of both the indexes, not only one indexes. If I only wanted row, I'll not specify this number at all then. But now because both the indexes are there, so both indexes will work independently, and then only the common thing comes out because the output has to keep in mind of both the indexes constraints. Perfect. Any questions, anyone? Okay. So I hope it's clear to everyone. So same way, like let's say if you want second row, so you'll say this way, ARR 2D. Only second row, all the columns, one and the same thing, however. Okay. So this can be done. Just one more example. Let's say I'm having a lot of integers now. Just this example will help you to understand what we are doing over here. So what happens is from third row all the way till sixth row, never last row is never included. So 0th row, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth row. So from third row, all the way till sixth row. 7 is not included. Last index is never included. So this is what this does. Now what does this do? From first column all the way till last column, because column is mentioned after 1. So from first all the way till, like if there are any n columns, it will go till n length. But in our case, n is only 3. So this is what this code selects. Now because both of them are there, and both of them have to keep each other constraints in mind. So only the selected portion, this part, comes over here, the common area, as a output. Clear, everyone? Any questions, anyone? Roshni, you're posting messages me too privately. You can post them to everyone so that everyone can, if I answer those, everyone will be able to understand. Okay, perfect. Okay. Now let's look into comparison. Nothing which is unique to NumPy and it is also very good. For example, if I say np.a range from 14 till 34, I have some numbers now. Okay. Now just see what happens, and it's amazing. So this is a array. Okay, I'm having this as a array now. Now if I say ARR greater than 24 with list tuple, this will not work. You'll get an error over there. But here, when I do this, see, it returns your NumPy array, but with false and true, like Boolean values. This returns your NumPy array with Boolean values. And if you see this type as well, like if I'm saying type ARR greater than 24, it's a NumPy array only. So you get a Boolean array as output. But if you simply take this logic and index it, means look closely, I'm saying ARR, and I'm simply indexing this logic now. Square bracket ARR greater than 24. Once I do this, can you see what happens? It filters out the data wherever this condition is true. Or in other sense, wherever true was present, only those index values are shown to you as output. Do you see this? Now this is not at all possible with arrays and or any other thing. Okay. Same way, ARR greater than 24, you can store this in a variable. Again, this is a NumPy array only. And once you run this, it will do the exactly same thing. And you can do it for a number as well. Like it's not necessary that you'll have to pass in the whole thing directly over here. No, you can simply pass in a number as well. Bool array, ARR, what it is representing, ARR greater than 24. So this is what is also possible. Clear to everyone? Let's cover these in the next class then, because we've got a lot part. But yes, is it clear to everyone? Any questions so far? Any questions, any doubts, anyone? So we'll continue from this only in the next class then. Okay. From this NumPy operations, then concat, then broadcast, because we still have a few more things to cover, which will not be able to cover in this class itself. Of course. Sure, Rahul. So now in case if you have any questions, please post in your questions in the chat. I'll be happy to take those up. And in case if you do not have any questions, I've shared the feedback link in the chat. Request you to please provide feedback, and then you can drop from the class. For feedback, only 5 is termed as good. Other than the 5, it is not termed as good. You're also free to provide in your comments as well. Okay, so please provide the feedback. It will be helpful. And then you can drop from the class. And in case of any questions, please post in your questions in the chat. I'll answer those and then you can drop. Also, I'll be uploading the notes as well as the codes on the LMS portal for all of you. So any questions, anyone? Any questions, any doubts? Thank you, Toby. Thank you, Bharat. Thank you, Rahul. Thank you, Sudhir, Vaibhav. Thank you, everyone. Any questions, please feel free to put in your questions.
Thank you for your wonderful session, Rahul, and thank you everyone for your participation. Once we wrap up the session, you can see survey feedback form in your browser. Please rate us the session between 5 or less than 5. It will improve the upcoming session.
Thank you, Pavitra. Thank you. Okay. So I do not see any questions coming up. So thank you, everyone. See you in tomorrow's class, where we'll continue with NumPy and then move to Pandas. Thank you. I'm also dropping.